Hello, welcome all. So today we'll be generating a heat map using the R programming software. So for that we need to download certain files. So for that just open your internet browser and search GEO database and press enter. So just go to the first link that is coming onto your screen, and next what we'll be doing is that after this page opens we'll be type our keyword. So here you can see that already I have searched for several keywords here. So keyword or GEO accession number, which is a type of unique identifier number for a type of data present like deposited in the GEO database. Okay, so for that we'll be typing GAC 240480 and press enter. So after this, uh, this page will be opened, and as you can see, it is the gene expression profiling of glucocorticoid receptor signaling in primary prostate cancer associated, which means this data was taken from prostate cancer patients, and this the significance of this data can be said as from four prostate cancer patients were treated for 24 hours in three different treatment groups, which means that there was a certain time interval between the data taken, which makes it much more significant. So, if you want to study this data in detail or this experimental whole procedure in detail, so this is the link to the page, rather to the paper. So just copy it, and if you open it into a new tab, then this link will be visible to the paper, and full PDF version is also available. As you can see, here it is, full text link is given. You can read it. Okay, so just closing this tab and coming extreme below, we can see that there is a supplementary file in the extension .tar, which means that it is a zipped file. For running into a system in R, we have to unzip it. That rather we can say that we have to untar it. So here you can see the size like around 300.7 MB, and it is a cell type of file. And this CEL means that cell intensity file, like it stores all the process cell intensities from the primary image in a DAT or a data file. It is also used to store the gene expression data. So for that, we'll be downloading this HTTP format. Here you can see it is downloading. The download is in progress. So now, as you can see, that all my files have been downloaded in a zip format. So in order to unzip it, I have to simply select all, because I have that, you can see, WinRAR. So if you don't have WinRAR, just you can download it from Google, because it makes the extraction format a hell lot easier. Okay, so just right click it, and I will be extracting it here. Extract here, and once, as you can see, it is being extracted. New files are being generated here only. So just we have to just wait. So now all my files have been extracted. So what we'll be doing next is just to create, I'll create a new folder here, new folder, and I can name it as a cell files. You can name it according to your need. Now I'll be like press Control and selecting the and we select the extracted files. It is 13, 14, 15, 16, and so on. I'll be like selecting all these files from here in the extracted files. You can see the extracted files are having the cell file format rather than the extracted file, the zipped files were having WinRAR archive format. Okay, so I'll be selecting all these, Control X, I'll be cutting that and we'll be pasting it here. So as you can see, all my files have been unzipped and have been extracted here. So just to make sure that all my files are in place, proper place, I'll be just going back here, and yeah, I can see that after clicking onto this folder, all my extracted format files are here. Now I'll be just like minimizing this window and we'll open RStudio. Here you can type RStudio, or if it is available in the desktop, you can directly open that tab. So I'll be opening RStudio and simultaneously I'll be opening the R script in another parallel window. So for that, let's wait for the R to open. It's taking some time. Yeah, it's opening now. Yeah, and you can see that the RStudio has been opened. And as you can see that, just wait a minute, it is opening. Yeah, it is opened. So now we'll be simply writing all these uh, comments into R. Just select it up to BIOS manager, copy it and paste it into this console of R. Just paste it and press enter. So these are the packages that we use in R. For example, this bioconductor and the oligo packages. They're both used in R for particularly analyzing the genomic data such as microarrays, RNA sequencing analysis, and due to the extensive visualization capabilities, as we will see later, and reproducibility, you can also say, and their scalability is unmatched for large data sets. And here next you can see that the next comment is oligo. It is a like part of the bioconductor project and it is designed for oligonucleotide arrays, right? Especially for like Affymetrix and Nimble platforms. The main purpose is to streamline the bioinformatics pipeline. Next, you can see we'll be copying this one and paste it. We'll be installing oligo. Like, is there something wrong here? So now after my files have been extracted, I will be opening the RStudio and the Word file where the R script is written, and I will be simply copying it and pasting it into my R console. That is, I have copied that and will be pasting that and press enter. So now we are using the packages called bioconductor and the oligo packages. These are generally used for analyzing like genomic data such as microarrays and even RNA sequencing analysis. And what kind of advantage they provide is that they provide like extensive visualization capabilities for genomic data and reproducibility, and even like high scalability for large data sets. And to be very specific, this oligo package, it is a part of the bioconductor project, and it is defined for oligonucleotide arrays, especially for the Affymetrix and Nimble platforms. The you can say in a common term, that the main purpose is to streamline the bioinformatics workflow. Next, after the first command has been given, next we'll be selecting this BIOS manager, and we'll be giving the command to install this oligo package. Just copy it and we'll be like pasting it here. Then press enter. As you can see that there is a red button blinking out here, and something is being downloaded, like Pan Studio or Studio.com. It is still blinking so that the program is running in the behind. Next, we'll be copying this load the oligo package. Now once we have installed it, so here is the comment coming update all some none. So if this comment comes into the screen, you will press A and press enter. Otherwise, you have simply have to ignore that if the message doesn't appear in the screen. So now we'll be selecting this, we copying this. Once we have installed the oligo package, now we want to load it. Load the oligo package. So it is once again this red button is blinking here. So it is loading the oligo package. It will like take some few minutes. Next will be like selecting the set our working directory to where my sales file are being located. Means where my sales files like cell files are being stored. So I know exactly where it is stored, where they kept. So as you can see, it is being downloaded here. So it has been downloaded almost, I think, yeah, downloaded 533 KB of data. Now I'll be copying this command. Still, it is the red button still is there. As you can see, packages successfully unpacked and MDS sum checked. So the file has been loaded. The package has been loaded. So now I will be giving the next command, that is set the working directory. I'll copy that. Still the red button is blinking, so that you can see that the program is still running behind. So I'll just wait a few seconds. Now I'll be deleting this whole thing. Once I pasted this command, I'll be deleting this whole thing. Uh, See, it is still being downloaded here in the background. Yeah, it is downloading. So just wait for that. And in the meantime, I will be like selecting this pathway, that is in my PC documents via workshop cell files. I will be selecting this whole copy, right click onto that tab, copy address, and I will be simply minimizing this window and like paste it here. Oops, the whole thing has not been copied yet. So once again, I will be going there. I will be right click that, copy address. Let's hope that it will get copied. I think it is so as you can see that once my oligo version has been downloaded, it will the final line will be like this: welcome to oligo version 1.68.2 or some other versions which your system is compatible to. And now next we'll be setting our my working directory, that is set wd, set for working directory, that is I have set to this file. And once my working directory is being set, once again I will be using is use BIOS manager to install the PD Clarium D human. Okay, this is simply speaking PD Clarium D is used for working with the Clarium D human microarray analysis, enabling like us to link probes to the corresponding genes present there. So once again we'll be copying that, copy it and simply paste it out here. And once again we can see that this red button is blinking. So it is once again downloading the files. We have to once again wait for a few minutes. Next, so just wait for a few minutes till the file gets downloaded completely. So yeah, you can receive this kind of errors. It is simply due to the security policies available. Otherwise, just ignore that. Now we have to load the package. So for that, we'll be once again copy this and pasting it here. We'll be loading the package. Yeah, it has been loaded here. So now we'll be loading our cell files using the oligo. So for that, we have to like copy paste once again the same procedure for the next command. Just copy it and paste it here. Once again, enter. So after we can see that the platform design info loaded. So now it is reading all the sales files that I have provided. The path previously, this is the working directory path I have provided previously. You can see all the cell files are being read in this format, that is .cel format. So for this reading purpose, extraction is must. Otherwise, your files will definitely exhibit an error. So next we'll be performing is that RMA normalization. Just let me give you a brief overview. RMA normalization means that robust multi-array average. It is generally used to remove the background noise, you can say. It also even makes the arrays compatible by ensuring even distribution of probe intensities, and like it generates an overall expression value, simply averaging the formats. Now once again we'll be copying that. Still this red button is there, so I think it's something is running in the background. So we'll be just waiting for a few minutes before we proceed to our next command. Just wait for a few minutes, because if we like give this command while another command is running, it might show some kind of anomalies in the next command. So we will just be waiting for a few minutes, and once this red button disappears, we'll be giving our next command. So you can see it's still running here. You can see if I click this button, it will interrupt art. So I'll be interrupting this running program. So yeah, this red button is gone. As you can see, these two arrows have come out, and we'll be pasting that. Uh, Sorry, not this one. I made a mistake. One second. Simply deleting these files. I'll be pasting the next comment, that is perform RMA normalization. Yeah, this one. Perform RMA normalization of this normalized data will be generating. So just copy paste that and press enter. Once again, you can see that this red button is there. So once again, the normalization process is being performed. So once again, you have to wait for a few minutes before we proceed to the next command. It is blinking, and this red button is still out here. So normalizing the data will take some time, because like it is averaging all the data sets, and it is making also the arrays comparable by making sure that there is an even distribution of the probe intensities in all the data sets. So and it is also like removing the background noise, as I have mentioned previously. So like it is like for that reason it is taking some time. So as you can see that the normalization has been performed. These three will come onto your screen. That is background correcting, normalizing, and finally calculating the expressions. So once again, I'll be giving the next command, that is display. Sorry, that is display the first few rows of the normalized data, just to ensure that the files have been normalized. So I'll be just copying it, pasting it, and enter. As you can see, the data has been normalized in this fashion. And next we'll move to save the normalized data to the CSV format. Once again, copying that and pasting that, enter that. So now, once it is done, as we know that CSV stands for like comma separated value. It is a kind of text file that we are generating, which stores the data in a comma separated format. That makes the production of the heat map quite easier. So now once we have still the red button is running, so something is running in the background. So now I'll be loading the necessary libraries once I have installed them previously. Now I'll be calling these libraries and we'll install it. Let's see. Let's wait for a few minutes. And, yeah, it is being done. So we'll be just once we have run these files, the normalized data to a CSV file, we can like load down necessary libraries. Once we copy that, we'll be pasting it here. Yeah, it is done. Next, we'll be moving on to the next command. One thing I would like to mention here, that you can see some kind of exclamation and the two written capital letters. The exclamation means that it's a logical negation operator. It flips the result of the expression. So, like uh, like if we give expression require namespace biopsy manager, it means that if the biopsy manager's package is not available, okay, and the capital true means TRUE, it denotes that is the checking is happening, the check procedure is happening quietly in the background without like displaying any kind of output or whatsoever. Okay, so we have given the command up to this install libraries. We'll be giving the next command, that is installing the heat map. So I'll be pasting the command once again here. Yeah, it is running in the background. You can see here. Next, I'll be waiting after a few minutes. I'll be giving this command, that is install the oligo. So let it install it. Yeah, it is done. So next, I'll be giving this command, install oligo. Once again, it is being downloaded here. It will like take a few minutes. Yeah, you can see it is being downloaded here. So we'll be like pasting the next command, that is we'll be loading the libraries. So once the libraries are being loaded, we'll once again give our set path, the working directory, copy that, we'll paste it here, and simply as previously, we'll be simply deleting this one, and we'll go to our file path, copy address, right click copy address, and we'll be pasting it here and press enter. So once our path is being set, so we'll be giving the next command, that is perform the load the cell files and perform RNA normalization. So you can see that the platform in design info is being loaded, and after being loaded, it will read that particular CEL files and will perform the RNA normalization procedure. So here you can see that the platform design information has been loaded. That is, all the cell files have been loaded here, and the normalized data has been generated using the RNA normalization. So we'll be extracting the data. We'll be giving the next command, that is extract expression data, pasting it here, and give enter. Now I'll be selecting the most top 50 most variable genes. You can change these values according to your own need and for the experimental purposes. I have given the 50 most variable genes. So once again, we can see that the red button is running the background. So it is selecting the top 50 most variable genes. Now ultimately we are left with this thing, that is to generate the heat map. Next, once this red button blink, stops blinking, I will be simply copying this one. I already copied and will be pasting it right here. Now we can see that the red button has stopped blinking. So I will be simply give the command generating the heat map. Rather, before like copying pasting it, I will be like changing this number 50 into 1000, so that the clarity of the heat map becomes quite better. So just be copying that, and now I'll be doing a full screen Star Studio. I'll be like reduce this size, I'll paste it and press enter. So this is the heat map that we have generated from this data. Just click on zoom and it will open one new tab, dot zoom, and just you are maximizing it. We can see this is the type of heat map that we have generated using this R programming software. Here you can see that the values are ranging from plus 1.5 to minus 1.5. We can say that the red ones or the deeply red ones are the highly expressed genes or the highly upregulated genes, while the deep dark blue ones are the lowly expressed or the downregulated genes responsible for this type of prostate cancer. So generally, heat map produces a high quality matrix and offers statistical tools to normalize input data. Even we can simply say that heat maps provide a pictorial visualization of the data we have generated, we have input into it. So that's for it. That's for it for today. We'll be like closing these tabs, and thank you all for this. And